There were several questions about Assignment 13, Problems Related to Fundamental Theorem of Calculus, Part 1. Before we talk about this, let's get some context. If I asked you to take 196 plus 47 minus 47, if you stopped and thought about it for a moment, you'd realize that there was no need to first add the 47 and then go back and subtract the 47 because you're just going to end up with 196. Fundamental Theorem of Calculus Part 1, FTC 1, is similar. If we have a function and we first integrate it and then we take the derivative of it, and we're taking the derivative with respect to x, where x was the upper bound, then all we end up doing is substituting, replacing the t with the x here. There's no need to first take the antiderivative, then go back and take the derivative to get the answer, right? If you stop and think about it, the derivative and the integral, doing them back to back is going to be similar to adding 47 and subtracting 47. So the first question was about number 28. In this case, I could go through and find the antiderivative, sub in the values with Fundamental Theorem of Calculus Part 2, and then take the derivative. But here I can just recognize I have a function. I'm going to integrate, and then I'm going to take the derivative with respect to x. X is the upper bound, so all I need to do is replace these t's with x's. And that's my answer. For reference here, you could have gone through and found the antiderivative, subbed in the values, and then taken the derivative, and after all that work, you get the exact same answer. Okay, so the next problem, the first question I had was about the notation. This is equivalent to this integral. So we can just move that dp over. So again, I could go through all the steps of antiderivative, derivative, but what I notice here is that I have the derivative with respect to x, and then I have a function of x. So I'm going to do this problem in two ways, one a long way and then two a shorter way. So what we might notice here is that we can use the chain rule. So I might start by saying, let u equal x cubed, then du dx is 3x squared. And I might remember that if I have a function and I have an inner function, remember we had that inside function that we ignore and then we take the derivative of the inside function? Some notation for that would be dy du, du dx, right? Take the derivative with respect to the inner function and then take the derivative of the inner function. So I'm going to do that here. I'm going to make this now d du, I replace my x cubed with u, and with the chain rule in the end, I'm going to have to take the derivative of that u term. I'm in good place here to use Fundamental Theorem of Calculus, Part 1. This ends up being 1 over u squared du dx, but I don't want my problem in terms of u, I want it in terms of x. So I'm going to make this 1 over x cubed squared times du dx is going to be 3x squared. So that ends up being three over x to the fourth. Now, let's see, it looks like I've planned my space badly here. I could have, so this is one solution path. I could have recognized right here, oh, this is just a chain rule problem. I'm going to have to sub in my x cubed and then take the derivative of x cubed. So a second path would have looked like this. Go ahead and sub in the x cubed and then take the derivative of x cubed. So this will be 3x squared over x to the 6th, which gives me 3 over x to the 4th. As you become more experienced, you might not need to do this solution in red. You could do the purple solution. All right, then there was a question about number 31. Again, we can write this guy as d dx, 0 to x squared The beauty of FTC1 is right now in Calculus 1, we don't know how to take the antiderivative of this integrand. We'll get that in Calculus 2. So our only option really is fundamental theorem of calculus part 1. So I can go with my shorter route here where I say, oh, I have x, and then I know that this is a function of x. I'm going to have to sub in the x squared and then take the derivative. So this will be 1 over x squared squared. I replaced my t with my x squared. And then I need to take the derivative of x squared. It's just my chain rule. 1 over x to the 4th plus 13 times 2x. Here I don't have any cancellation because I don't have a 13x, I just have a 13.